We're going to kick off this unit talking about bisectors of triangles. And there's two particular bisectors we're going to be looking at, the perpendicular and the angle bisectors. So we're going to start off with the perpendicular bisector theorem. So it basically tells you that if you have a perpendicular bisector, then the endpoints of a segment are equidistant to that perpendicular bisector. So let's write it down first and then let's look at the picture and see what that means. So again, this basically says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of a segment, creating a triangle. So that's where the triangle comes in here. So what we need to see is we need to be given that L is the perpendicular bisector of AB, and then X is on that line L, then we can conclude that XA is equal to XB, or rather that they're congruent. They're the same distance away. So that's your perpendicular bisector theorem. Okay? Then we can use the converse of the perpendicular bisector theorem to determine if a point is on the perpendicular bisector. So this is basically the opposite, right? If we know that the distance from an endpoint to a point on a line is equidistant to the other endpoint, to the same point on the line, then that line must be the perpendicular bisector. So once again, let's write this down and then let's look at the picture. All right, so once again, if any point is equidistant to the endpoints of a segment, that point is on the perpendicular bisector of that segment. So here we're given, for example, XA is congruent to XB, and you see how A and B are the endpoints of the segment. Then we can conclude that X is on the perpendicular bisector of AB, and in this case that would be the line L. Okay? So let's go ahead and use these theorems to help us out with a couple examples. So if you look at example 1, I want to find the length of BC. So what I'm going to notice here is that, hey, look, AB is 38 and AC is 38. So if we know that AB is congruent to AC, that means AD is the perpendicular bisector of BC, because again, if that point is equidistant to the endpoints, then it must lie on that perpendicular bisector, and this is the converse of the perpendicular. Oh my gosh, my handwriting's awful today. It's the converse of the perpendicular bisector theorem. Right? So if that's true, then we know that AD is bisecting BC, so then that means BD should be congruent to DC by the definition of bisector, which then tells us BD should equal DC, and that means BD equals 12, right? Coming from what's given, which then tells us that BC should equal 24. So it got a little messy down at the end, but it kind of follows with the idea of what a bisector is. Okay? So if we take a look at part B, what do we know here? Well, it doesn't look like A anymore, but what do these marks down here tell me about UW? Well, hopefully you're seeing that UW is the perpendicular bisector of TV, right? And if that's true, then UT and UV should have what relationship? Well, they should be congruent, right? By your perpendicular bisector theorem. Which then tells us that UT should equal UV. And then I can substitute, say 3x plus 9 equals 7x minus 17 to get the value x equals 6.5. And then plugging that in, we should get TU equals 28.5 units. Let me move that up so you can see that. Okay, so what we're using these theorems for is to help us set everything up, and you'll notice I'm writing things out, reasoning it out kind of like a proof. You don't have to do that here, but I want you to, again, keep it in mind so you can explain why things work. Okay, so that's the first thing we're doing with perpendicular bisectors. The other thing I'd like you to be able to do with perpendicular bisectors is write an equation. So kind of going back to your Algebra 1, let's think about how do you write an equation in, here I'm asking for point-slope form, so you want to make sure you remember what that is, versus slope-intercept form, of the perpendicular bisector of the segment with endpoints C and D. So I'm going to go ahead and graph these 2 points to draw my segment, and you might be thinking, well, do I have to? The answer is no, you don't, but I'm going to show you why it might be a nice idea to do that. Okay, so the first thing I want to do is I want to think about how do I write an equation of a line. So remember, point-slope form is y minus y1 equals m times x minus x1. So we need the slope and we need a point. And then the slope needs to be perpendicular. So remember, perpendicular means opposite and reciprocal. Slopes, right? They multiply to -1. So to find that slope, I'm going to take the original slope and do the opposite reciprocal of that. And this is where I kind of like to count, rise, and run, but you can use your slope formula if you'd like, but from C to D, it's up 1, 2, 3, 4, 5, 6. So positive 6, and my run is 1, 2, 3, 4, positive 4. So that gives me a slope. My first slope, I'm going to call that M1, is 6 over 4, which reduces down to 3 over 2. Then my perpendicular slope should be -2/3 because multiplied together they equal -1. If you wanted to do a slope formula, perfect. Could use the same thing. 1 minus -5 is positive 6. 10 minus 6 is 4. We still get 6 over 4. So the first thing you want to do is find that perpendicular slope. Then we need to think about the bisector. So remember, bisector means it'll intersect at the midpoint, right? It cuts in half, which means it'll intersect at the midpoint. So we're gonna want to find the midpoint. I'm going to call this point capital M for midpoint. Remember that formula is x1 plus x2 over 2, y1 plus y2 over 2. So we're going to go ahead and plug that in with your coordinates. 6 plus 10 divided by 2, -5 plus 1 divided by 2 is going to give me 8 and -2. Okay? So that is now going to become the x1, y1 of my point slope form. So there's my x1, there's my y1. Okay? Then it's a matter of just putting it back into the equation and writing the line. So your perpendicular bisector is y minus -2 equals -2/3 times x minus 8. Simplify that point slope form so a double negatives become a positive. And since I'm not asking you to solve for y, you can stop right there. So what you want to do is make sure you look at the directions if I'm asking you for point-slope form versus slope-intercept form. But for this problem, we're just asking for point-slope form, so I can stop and box this equation y plus 2 equals negative 2/3 parentheses x minus 8. Okay, so we're going to stop here with the video, and then in class we'll talk about angle bisectors and go over the last couple of examples. Please make sure you come back to class with questions, especially if you need to review how to write equations of lines, because I know it's been a little bit since we talked about it back in, the chapter about parallel and perpendicular lines and angles, so it might have been a while. Okay, thanks for listening.